Hmm. First, I need to convert the original K-pop track into MIDI values. So that's where I use Algo. And two, I need to store the MIDI values into a list. And then I need to hmm, play play melody. But how do I get the timing? Like the tempo? Hmm. Okay, so this one I can just um reuse my karaoke app algo. So that has that MIDI value stored out. And that I can then base off AI music generator. Yeah, should be pretty simple. Hmm. Okay. Hmm. Okay, let's try this. Hmm. Let's music. I think this and Inago. So, uh, which one did I use? Audio processing, analyze vocal, and yeah, I think those two. Alright, so I've already done some of the base work in my previous videos, so I'm just gonna try reconfigure it for the purpose of converting K-pop music to piano covers. I'm not sure if this is gonna work, but who knows? Alright, so let's just open up all of them. Yeah, I'm using Notepad++ because apparently it's faster and it's easier to use. So yeah. Okay, what do we have here? Alright, I'm gonna open up the command prompt. Already have a virtual environment set up so for this. So we have all the dependencies installed. So I'm just gonna make that smaller. And this folder is called piano. Okay. Uh, Alright, let's try this. Oh wait, can you guys hear my audio? Yep, you can. No module named src. Oh, I've got to import the rest of the folder. Alright, so music code. Hmm. Yeah, that's what I want. Okay. Okay. Alright. Cool, that works. Okay. Did you guys hear that? Hopefully that worked. Okay, so we're now able to generate a note. Now we have to try. So that note only played a pitch of 60, so a MIDI value of 60. So just for context, this is what we're trying to do. So what we're trying to do is we're going to download a K-pop music track, and we're going to get the frequencies of that music track. And once we get the frequencies, we then use this formula to convert those frequencies into a MIDI value. And a MIDI value is basically a number between like 21 and 108. And each MIDI value represents a note on the piano scale. And so that's the goal. We're going to try to convert those frequencies into their corresponding MIDI value. And then we're going to use what I just demonstrated here, this library, to then play those MIDI values. I've yet to work out how to get the timing of the MIDI values correctly because sometimes notes are played like fast or they played slow. So, but we'll try to get the notes down pat, and that's the goal for today. Yeah. Oh wow, there's so many people in the chat already. Hey guys. So to answer your question, Lizzie, I code in Python. Mm-hmm. Uh, yeah, yeah. I don't think this has a lot of maths, but it's just a lot of brain power. Yeah, yeah. Don't treat this too seriously. Like I don't know what I'm doing right now as well. So yeah. Also, just it might be a good Q&A session. Yeah. Okay. All right. What do I do first? Let me get the yin algo. So let me check. Going to here. Oh, I've got to import my yin algo. Nah, not this one. Karaoke app. Oh, yin algo. That's what I want. Okay. Cool. So just for more context, yin algo, or also known as yin algorithm, is a algorithm that converts or that detects the frequencies of the music track. So we're going to try use that. So let me just inspect the code of the yin algo. I'll try my best to explain what's okay. Okay, so we need to get a sample. So let me just get a sample track. I should have some music tracks in my folder. Yeah, I have some pre-downloaded. So let's do Jungkook My Time as a sample. Yeah, let's try to do that. I don't think there have been piano covers of that song so far, so might be the first one to do it with AI. Okay, so let me just change the name so there are no spaces. Time. And let's change it to my time. Okay, this should be good. And this has an initializer right here, so I can just play that. Boom. Oh, you. Takes a long time to load. Oh no, error. Uh, so I can see here, this is where the struggle begins. Trying to like just work out what's going on. Okay. got to do with the tracks, audio processing. Probably could do something with this. Command doesn't work. Let's go do with the command. Guys, if you're good at coding, just let me know if you have any suggestions because I'm struggling already. And guys, let me know if this is boring you. Yeah, like it's just me just looking at code. So yeah, this is basically how I prepare my videos. I just do this. I waste like my whole day just fixing one error, and then eventually I fix it, and then I spend another whole day editing my videos. So a lot of work goes into like each of those K-pop analysis videos. So yeah, this is the true behind the scenes, no fakeness. If I don't know, I don't know. So yeah. Oh, wait, can't open. Is it because of? Oh, did I even specify an audio file? I didn't. No, wait. If I just take this away, does that work? Oh no, still the same. All right, let me just try the full path. Sometimes the relative path doesn't work. You gotta try do the whole. Oh wait, is this even a WAV? Oh, it's an MP3 file. I'm so stupid. Oh, okay, guys. So did you see what happened there? So I was trying to detect a WAV file, but the audio file right here is an MP3 file, so that's why it doesn't work. All right. So this should hopefully work. So like sometimes these stupid oh no, it doesn't work. So it can't open in okay, so we've got to convert this MP3 file into a WAV file. All right, so there is a solution for that. I think it's called ffmpeg. I forgot the command. Right, let me just Google search. Convert MP3 to WAV. So again, this is also another reality of coding. You just end up Googling everything and like checking Stack Overflow. So yeah, like I'm not a genius. I'm just a guy who knows how to research. So hopefully that I'm not sure. Hopefully that inspires some of you guys because I think coding, as you see on the movies and TV shows, looks very intimidating, like very big brain genius. But in reality, we just end up looking up stuff. So all right, cool. Here we have this. So I'm gonna type in this command. Let me make this a bit bigger. So ffmpeg dash I file name is mytime.mp3 and I'm gonna convert it into a WAV file. Boom. All right, and that's done. And as you can see here, we now have a WAV file for my time. So let's check if it works. Yep, hear that? Yeah, cool. So hopefully that should work. So let me now go back to the code and change this to a WAV. Oh, no, 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 no. I don't want to do that. Wrong command. Oh, there we go. Oh, oh yeah. Oh, okay. So, okay, I got a copy there. So, do you guys see that? So, right here, the computer detected the frequencies of the of what am I talking about? The frequencies of the audio file. You see here a lot of numbers, yeah? So you see 95, 80, 94. So what we have to do now is convert those frequency patterns into MIDI. Yep. So how are we going to do that? Oh, this is hard. Okay. All right. So let's go back to the drawing board. So what's the formula for MIDI? Okay, it's oh, where's my stylus? All right, there's my stylus. All right, hopefully you guys can. No, it doesn't work. Let's see the chat. Yeah, how's everyone's day so far? Good? Hope everyone's doing well. Yeah. It's really hot here in Sydney. It's 40 degrees today, which, wait, what's that in Fahrenheit? 40 degrees Celsius to Fahrenheit. Yeah, so that's 104 Fahrenheit in like America terms. So yeah, it's a really hot day today. So I want to stay indoors. Okay, so MIDI value. Why is this not working? No, it's not working. Okay, so M equals 12 times log base 2 of frequency over 440 plus 69. All right, so that's the formula we want to codify to convert our frequencies to MIDI. For those who joined late, MIDI is basically a number that represents a note on the music scale. So the reason why we have 69, so let me just briefly explain the formula. So M represents MIDI. So let me break that down. M means MIDI. 12, why do I have 12? I think that's because we have 12 octaves. Uh, is that correct? Oh no, 12 equals an octave comprises of 12 semitones. So that's why we have 12. So these represent the semitones. I'm not a musician, so I don't know that much music theory, but a semitone is basically what's a semitone? Wait, I forgot what's a semitone. Oh my god, this is embarrassing. A semitone is a half a step. Okay, so that's a semitone. Basically a note that runs for a long time. Then we have our frequency, which is basically what we saw on our screen right here. So let me just get that. So these numbers are our frequency, and we have to divide it by 440. Why do we need to divide it by 440? That's because 440 is represented at A4, and A4 is this note, 69, hence why we have 69. So both 69 and 440 represent the A4 note. Yeah. Okay, so we got that. So hopefully that you mean 69 for the memes, yeah. So hopefully you know the formula. So let's try codify it. Already codify. Actually, let's make this fun. Let's actually do this again. I don't think this has been prepared. Just not. Actually, no, we have not yet codified this bit, so we just leave it in. Okay. All right, let's just close this. Mm, let's just delete this and then just create a new file. I wanna do this over again, like in terms of the MIDI conversion. I did it before for my karaoke app algorithm, but I wanna try it again, see if I still remember how to do it. And also, it's more fun if you see me struggle, right? Yeah, it's more fun, right? Okay, let me just save this as MIDI conversion, and we'll save as a Python file. Okay, so we're gonna import. So we're going to from audio process now. From the what am I doing? Okay, so we're gonna get rid of this. I'm gonna do from midi conversion import rec to midi. That's gonna be our function. So here, def rec to midi. We're gonna take in the frequencies as our parameter. All right, so let's think how we're gonna do this. Okay, so there's going to be a list of frequencies. So there's going to be like, frequency 1, frequency 2, frequency 3, etc., all the way up to frequency n. And we're going to loop through each. So we're going to loop through each element. And for each element, we're going to apply this formula. So let's just try write down that math formula in programming terms. So I'm using Python for those who are curious. My favorite language actually not Python, it's actually Java. Yeah. For those who don't know, Java is it's a very useful language. It's used in many Android apps. Yeah. Um, mm. And it's a pretty stable language. My second favorite will be Node.js or JavaScript, which is actually probably the most useful language to learn right now because you can build websites with JavaScript, or if you want to go on server side, or basically if you want to do stuff that's not related to the internet or to websites, there's Node.js, which is still very useful for building a tons of stuff, which is you can also build like some machine learning apps with Node, but it's not as widely supported compared to Python. Python's probably got the most extensive library for machine learning. And Python's also very useful for data science. So if you're into data science, I suggest learning Python first. Yeah. Yeah. So yeah. Let me know if you have any questions, guys. Like I don't want to just code and not talk. Like I need, yeah. I don't make this boring for you. All right, so we're gonna live for each element. So let's just go convert the formula. So we're gonna do midi equals 12 times. Okay, how I'm gonna do log? Let me check how we're gonna log. Python logarithm. Log functions. Yeah. Geek for Geeks is like the best website for like your coding problems after Stack Overflow. So yeah. Will this stream? Yeah, yeah. This stream will be automatically uploaded once I finish the stream. Yeah. I don't know when I will end. I'll just end it when I feel like it. Yeah. So yeah. What time is it in? So where are you guys from? Are you mainly from like which countries? I'm wondering what the time zone is so I can end it at a good time. All right, so we have to, oh, so it's in the math library. Okay, so math log a base. Okay, so math log a base. So what's our base again? Base is 2, and a is what? A is in numeric value. So a would be your frequency value divided by 440. That should be it. 440. Is that correct? And also plus 69. Due to BODMAS, we don't need to put any parentheses because multiplication goes before addition. So this is where primary school math becomes useful. You can use that to code. So yeah, hopefully that inspires some of you to do your math homework. Yeah. Yeah. Is that correct? That was way too simple. That was underwhelming. Yeah, that's correct. Okay, that should be correct. Okay, dokie. Do I need to import math? I think I need to wait, do I need to import math? Oh, another technique that I like to do when I do coding is I like to test simple scripts in the command prompt. So for example, I want to test if there's a math library. Okay, there's a math library, math dot. Let's just check this out. So let's just say here. Okay, let's say we want to get a value of 60. So a MIDI 60 is equivalent to 261.63 hertz. So let's just test that. Let's just test that. So I'm going to go here, Control C, Control V. Okay, let me just print out. Oh. All right, so 12 times math.log 261.63. We should get around 60. If it works, then we should be fine. Oh wait, I messed up the brackets. Let's just do it again. Import math midi equals 12 times math dot log 261.63 divided by 442 plus 69. And I'm gonna print midi. Yep, 60. That's right. So the formula works. So we're gonna apply that. Easy. All right, so we're gonna use that, and then we're going to store the midi in a list, and I'm going to return the list. That's it. I think we can do this in one line. Okay, so I'll write down the long method for demonstration purposes, and then I'll write down the one-liner to show how we can easily code this. So basically, just do for FQ in frec list. Oh, and you can also instantiate. So you can do like a midi list, empty list. You can do midi list dot append 12. Oh, we've got to import math. Import math. Append 12 times. I already had this down. Yeah, that's it. And we're gonna call this FQ. And then we're gonna return midi list. So that's how you can do it in 4 lines. If you want to do this in 1 line, I think it's like this. You can just do return. This is gonna be this takes brain power. So it's return frequency and no x for no. It's return 12 times that. For FQ in frec list. I think that's how I can do it in 1 line. Does that work? Okay, I think that's how you do it. Let's just test this out. So all right, so we have this. So from file conversion import frec to midi, we got frec to midi. Yep, and we're gonna midi list equals frec to midi. What's our frequency list? Oh, pitches. So pitches is our okay, and then I'm gonna return midi list. Let's just comment this out. Let's just only print out the values. Hopefully this works. Oh, cannot import name frec to midi. Why? Why can't I import? Cannot import name frec to midi from midi conversion. That's weird. Should be able to. Oh. Why can't I do it? Wait, what's wrong? I should be able to do it. Wait, why can't I? Wait, let me just restart. Sometimes it just happens like that. Hmm? At line 220, why can't I import? Cannot import name. Is it the spelling? Oh my goodness. Midi conversion. Guys, help! Why can't I import? Hmm. Wait, are they not in the same folder? No, they are in the same folder. Is this not been saved? Oh, it hasn't been saved. Oh, okay, so okay, we're now imported. Okay, invalid syntax. Oh, why? Is this too? Hmm. Actually, let's just not be a try hard. Let's just do it the dumb way. Let's just do the dumb way. Sorry, guys. I want it to be cool, but let's just do the dumb way. Let's just do the slow way. Oh, let's just try that. Oh, what? Invalid syntax? Come on. Is it the spacing? I know Python, like the one annoying thing about Python is that it's so sensitive to spaces and tabs. Like, for example, if this line is only tabbed, but this line's only spaced, then it just ruins the whole thing. So that's an annoying thing. So let me do this. That should work. Yeah, I'm reading the chat. Yeah, it's just hard to read and code at the same time. Yeah. Wow, there's so many comments. Wow, I feel loved. Thank you. Why is this invalid? No. Um, what? What's right there? Ma- Oh. Ah. Thank you. Thank you guys. You guys are the best. You guys are the best. Yeah. Thank you. I would have wasted like another 10 minutes on that. Oh, another one. Can only concatenate tuple. Oh wait, we accidentally used a tuple. All good. We just delete that. Oh, we'll keep that and we delete that. That's better. Yeah, that should work. Mhm. Mhm. Oh, what a math domain error. Oh, it's one of those those cases, Alright, so just a math lesson. There's no such thing as log of 0 or log of negative. So if I just do like log -1, oh wait, actually that works. Yeah, log it's undefined, so you can't do a number that's 0. It's undefined, and that makes sense because some of the frequencies that we've converted have a 0 in them. So we've got to add in the condition. It's just simple if FQ is greater than 0. Actually, it doesn't need to be greater than 0. If it, wait, that's how to, can it be negative? Wait, can it be negative? No, they're all positive. But if it doesn't equal 0, then it should just do that. Oh no, that's if. If. Oh, all right, let's go. Computing in algo. Oh, that's beautiful. Do you see that? You see that? Oh yeah. Oh, that's so look at those numbers. Yeah, that's very nice. Let's look. Let's see this in the graph. So I have some graph functions ready. Um, oh, actually, let's just do this. Let's just do this ourselves again. I don't wanna. Okay, we're gonna use a matplotlib. Okay, how do we graph again? I forgot how to do the graphs. Just do it. Matplotlib. I'll just do simple line plots. Not yet. Can't hear it yet. I haven't. This is so for those who don't know, we're only at stage 2. We converted our frequencies into MIDI. We still need to do stage 3, which is the hardest step. Yeah. So this is just a warm up. This is just a warm up. You feel like you're watching Startup? Yeah. I'm like Namdo-san. Yeah. Well, I wish I could be like. I wish I could be like that genius is also like hot. Like dang, I'll be also very tall. Oh wow. I'm pretty tall myself, I think. Yeah. Okay. Oh, that's simple. All right. All right, what do we do first? We need to first create a. All right, so fig equals plt dot figure. Do I have the plt? Yep, I got plt set up. All right, cool. Plt dot fig, and then axes equals plt dot axes. Hmm. And then we'll just do what? Is it just. Hey, I don't even need to instantiate. Just plt fig dot plot. Oh, oh, there's the duration. All right, so we need to keep the duration. So what goes on the y-axis? All right, okay. This is what I'm trying to do. I'm gonna try draw a graph. Oh, sorry. So here is going to be our MIDI values, and here is going to be our time. So that track is around 4 minutes long. So it's going to be around 240 seconds down there. And we're going to try and make a graph so it looks kind of like this, that sort of style. So on the x-axis, we need a MIDI. On the y-axis, we need our time. That's how it works. All right, I already have the duration. How do we do this? All right, let's just do something. Okay. Oh, the track is Jungkook's My Time. Yeah. very sensual song. That's actually not sensual. It's actually a very wholesome song. If you read the lyrics, it's actually very deep. Yeah. Length of duration. And length of. Alright, we'll see if these two arrays align, and yeah, they need to align in order for the graph to work. Where am I from? I'm from Australia. Yeah, so where it's still like afternoon, daytime for us. Yeah. Just another. Yeah, that works. Yeah. Why is there so many? One, two, three. Oh, what? Invalid. Oh, it's probably not another one of those. Yeah, it's probably that. Oh, hi. Oh, another Sydney person. Hi, Jay. Nice to meet you. Float has no len. What? Oh, right. I'm so stupid. Duration is not an array. It's not a list. I can't do that. Oh, okay. I'm so dumb. All right. No. That's just how you do it. All right. That's better. Yeah, it is hot. It's crazy. It's so, yeah. Anyone here from Canada? I wonder what's it like in Canada, where I heard on TV, like just from movies and stuff, it's really cold over there. I wonder what's it like. Like I see Australia as like the opposite of Canada. We have like really hot days and they have really cold days, and we're both pretty chill countries. That's how I like to think of it. Yeah. All right. So this length of duration, 234.49 seconds. That's about right. Let's just verify that. Uh, yeah. So my time's about 3 minutes 54. 3 minutes 54, 234. Yep, that's about right. That's about the same. So that's correct. And there are 14,000 MIDI values in this. Okay. Hmm. Okay. Hmm. Okay. I'm gonna plot. I need to think for this. So. Oh yeah, we have a lot of crazy creatures and insects in Australia. Like last night, I saw a big flying cockroach. Oh, it's crazy. Like out of all things, right? Why do cockroaches need to fly? Like why were they given wings? Like they're already bad enough. Why do they need to fly? Well, lucky spiders can't fly. Yeah, so that's okay. Good night. Good night for those who are going to sleep. Sleep well. Yeah. Yeah, we have really nice weather here. Yeah. That one I'm really grateful for. Yeah. Okay, back to coding. So I'm gonna just show you. So when we do a plot, when we do a plot, when we call the plot function, the first value is the x-axis, the second value is the y-axis. So that's why the first value we're gonna do the duration. Wait, that's the 6 sample rate. No, we need to do length of pitches. So that's list comprehension. And no, not where not pitches. Sorry. Not doing pitches. Oh wait, they're not gonna align. All right, let me explain what I'm thinking. So, okay, let me just complete this first and now explain why I don't think this will work for now. The reason why this won't work is because the list of MIDI values, the number of elements in that list won't be the same as the number of values that will be on the x-axis. That's because there are some values which we couldn't convert to MIDI because some values was 0. So we're going to add in a condition. So we're going to add in a condition down here. Else, if the frequency value is 0, then we're just going to append the number 0 to the list. What that basically means is that at that particular point in the track, there was silence. So there's nothing. Yeah. Okay. So that hopefully that should be a parenthesis. All right. Brackets. Okay. That should be okay. Yep. So let me just set the axis. Set the title. This title should be MIDI values over time. Um, axis set Y label. It should be MIDI and X set X label should be just time. How do we show the graph again? How do we display the graph? Forgot. Yeah. It's POT. So. All right, if that works. I doubt it will work, but hopefully. Figure object has no attribute plot. Oh wait, just POT plot. That should work. Oh yeah, about that most consistent main dancer series. Thanks for. Okay, that looks completely wrong. But okay, yeah, thanks for raising that. Yeah, so I've been thinking about how I'm going to make this a more proper experiment because I realized when I first did it, I didn't think too much into it. I realized that just by comparing two dance videos of all different songs wasn't a very fair analysis. So I'm still thinking how I can make it a more fair analysis because yeah, it's a bit hard. So that video, in retrospect, I don't think is the best analysis because we're just comparing dances of all different songs and we're just doing two dance samples, which isn't the best. So hence why I've been doing this individual group series where I only take 10 or 15 songs of one group and only analyze for that group only because we're only comparing that group's performances. So that's a bit more fair compared to that most consistent main dancer series. So I've yet to think how I'm going to do it. I was thinking about like getting as many fan cams of a dancer and editing them together so you have like like a split screen of like four samples of of that idol doing the same dance, and I'm just gonna run the analysis as if these four like samples were four different idols in the same shot. I was thinking about that, but then the problem with that is you need to have really good fan cams, and it is not that many like clean fan cams, unfortunately, for like the same song. So yeah, it's a really hard analysis to pull off. But if you have any like suggestions, yeah, let me know because I'm keen to like redo the analysis. Yeah, I want to redo that particular analysis because I think I accidentally started a fan war. Yeah, yeah, I accidentally started a fan war. Yeah, so yeah, but I'll still keep the video up there just for just so that people can, because I'm open to constructive criticism. So everyone's got a fair point. So that wasn't a fair analysis. So I've got to rethink how to do it. Yeah. Um, no, I don't really use C++. I love to learn it though, but the thing is, I don't really make a lot of games. And I know C++ is really useful for making games and also more complicated software programs. Many like Microsoft programs are written in C++, but I haven't really worked on projects that require that sort of like language. So I just mainly be sticking to Python, Java, and JavaScript and Node.js. Yeah. Mm. All right, so let's just go back to the code. This looks very wrong. I don't know why it looks like that. Is this sorted? Did it? This looks so wrong. Uh, why is it? Why is it a graph like that? Uh, all right, guys, I'm gonna have to cheat a little bit. I forgot how I did the graph. I'm just gonna go back to my. So remember I did a video on how I analyzed Taemin's vocals? I did the exact same function. Yeah. I wrote it myself. I just forgot how to do it, and I don't want to spend too much time on the graphing, so I'm just going to look at how I did it. Sorry. Oh wait, did I even? Oh wait, I don't even have it on my computer. No. Oh, and it's in Sunday. For those who don't know, Sunday is my homemade AI system. I built the whole program myself, and it does a lot of cool things. Like you can have a conversation with it. It can open up files for you. It can do those K-pop dance analysis for you. So yeah, it's pretty cool. I was inspired by Jarvis in Iron Man. Yeah, so that's how I built Sunday. I think it's in Sunday bot. No, it's not in this one. It's very cool. No, where is it? Processing. Something GUI? No. Okay, let's just not focus too much on the graph. I think the graph is just a minor feature. Let's just work on the actual music. Yeah, I don't want to spend too much time on that. Okay. All right, step three. You need to play the MIDI version as a melody. So let's just go to our note sam example. Okay. All right, so this is the key. Hmm. I'm gonna import. Hmm. Okay, let's make this into a function. Uh, def. We're gonna call this create piano cover. For those who don't know, why am I doing this? Do you know how sometimes whenever a new K-pop program, sorry, a new K-pop video gets released, right? And then 1 hour later, like these piano YouTubers just release a piano cover like so quickly. You're like, wow, how do they do that? It's so crazy, especially because like there's no score sheet. There's like no score sheet for that music track, right? And they're able to just create a piano cover instantaneously. So I want to be able to try compete with these YouTubers with a program. So yeah, I think you know which YouTubers I'm talking about. Yeah, those piano K-pop piano cover channels. Yeah. Um, do I save my live streams? This is my first ever live stream. So yeah, this will be automatically uploaded to YouTube. Yeah. Uh, so let's just okay. Okay. So we're going to first get our MIDI tracks. And because we're calling in that file, we're going to not use the initializer right there. Okay. All right. And then, so this is what we have to change. So how are we going to do this? Right. All right. Let's just first test if we can. Let's just see. Okay. Let's just say pitch is 60 and pitch is 62. Does that play two notes at the same time or in succession? No. Okay. Let me know if you guys can't hear what I'm hearing. I'm not sure if I got my audio on correctly. Um, so this was just created. Oh, refresh. Wait, has it been? It's been outputted yet? Wait, did I output this correctly? Hmm? Shouldn't it overwrite that file? Let's just delete it. Let's try again. Wait, why is it not? Oh, I'm so stupid. I did. This happens, guys. Like I forget to call the function. Like I spend so much time writing the function, and I forget to call it. So yeah, this is what I got to do. Oh, actually, cool hack. So for those who know how to do, for those who are into Python, there's a cool trick you can do. So you can do Python dash I, the name of your file, enter, and then you go into the interactive mode. And here you can call your function. This is an excellent way to test your functions. Yeah, so that's how it works. So this should create a file. Yeah, there we go. Can you guys hear that? Let me know if you can't hear it. So, okay. I assume you guys heard that. But that's how, so that was playing two notes at the same time. So we gotta, hmm. play them at different times. So let's just, so I think duration is time. Time is 0. All right, let's just do time equals 0, 0, and then 1. Let's try that. Oh, there we go. Ooh. All right, so okay, so let me just recap what I just did. Okay, so um, let me use this file to explain. So in order to add a note, so how we're gonna write the music file is there are notes, right? And to add a note to the file, we use a function called add note. Now this add note function takes in um five, sorry, six arguments. So when I say arguments or parameters, think of them as data, just 6 pieces of information that it needs, okay? So the first information that it needs is the name of the track. Sorry, no. It needs to get the track, which so whenever you so what track is whenever you every audio file has like the left and right channel. Wait, is that correct? I think so. Yeah, I think that refers to left and right. Oh no, that's channel. Sorry. So channel refers to like the left or right channel. For our present purposes, it doesn't really matter that much. It doesn't really matter which channel we use because I think they're gonna sound the same. So it's just gonna be the first one. Track is okay. So what track is that you can play multiple um tracks at this at you can create multiple tracks at the same time. Because we only want to convert one music file, we're just going to do one. And for those that know, programming languages start from 0. So instead of counting 1, 2, 3, 4, 5, we count from 0, 1, 2, 3, 4, 5. So 0 means the first. Yeah. The third piece of information that we need to put in is the MIDI value. So we spent the entire past hour trying to convert frequencies to MIDI. That's the way we put that information in there. Then we have the duration. This is how long the notes will play. So let's brush up on music theory. There is yeah, this one's a good picture. So you have um the eighth note, which is half a beat, quarter note, which is 1 beat, half note, which is 2 beats, whole note, which is 4 beats. So the duration refers to like those beats, how long that note lasts for. So that's what I think it is. The last one is volume, which is pretty obvious how loud. Oh, sorry. Before we go into duration, there is one more before that. There is time. So time is when that note will be played. So if 2 notes have the same time, then they'll be played at the same time. If at different times, then they'll be played at different times. Yeah. So for example, in our I should put this at. Sorry guys, I forgot to zoom in. So if you couldn't see properly, that should be better. So 0 means this note will be played before this note. If we put them together at 0, 0, then that means these 2 notes will be played at the same time. So I'll give you an example. That's created and refresh. Yeah, hear that? They play at the same time. So given the information, we can then try create our K-pop piano cover. So we have our MIDI list from our other file. So we're going to make these our. So we're gonna do this. So volume's gonna be consistent, and we're gonna put this in the for loop. So I'm going to comment this out so that we can refer back to it. And I'm gonna do for MIDI in MIDI list. Pitch, we don't need pitch anymore, it's just our MIDI. Duration, we'll worry about that later. We do my MIDI dot add note track channel MIDI. Wait, does the MIDI accept floats? I don't know. We'll just work that out soon. MIDI duration. All right, so hmm, let me think. How are we going? Okay, let's just do a simple one. Let's just do a counter. Duration equals 0. We're adding duration. Volume's the same. And then once we finish that, duration goes up by 0. 0.5. No, 0. Let's try 0.25. This is gonna sound really random because I have not yet processed the how the melody is gonna work, but this should hopefully work. And once we've done that, bin open MIDI, right, bin file. Yeah, hopefully this works. So this is our first test of trying to convert MIDIs into a music melody. Hopefully this works. Oh no, it's not. Okay, I'm missing one argument. That's all good. Um, uh, time, track, channel, MIDI. Got the duration. Um, time. Sorry, that's meant to be the wrong one. Wait, sorry, this is supposed to be inside the scope. And I got them mixed up. It's supposed to be time that increments, duration, time increments, duration stays the same. That should work. Okay, hopefully that works. Local variable time reference before assignment. Oh, I forgot to, yeah, that should work. Wait, what? Uh, did I mention time before? Line 20. Ah, okay. Uh, do I need to put this inside? Hmm. All right, let's just try. Oh, required argument is not an integer. Okay, that's okay. We can just convert this into an integer. So what it means that I think what this error refers to is that this particular function only accepts whole numbers. So whole numbers are like, 60, 80, like 79, just any number that doesn't have a decimal place after it. In programming, we call these integers. If you remember our MIDI values up here, they have decimal places. For example, 52.9. That is called a float, which has decimal places. So what we need to do is convert this into an integer, which is, oh, this is where, do we round up or do we round down? I think we round down because it will be a completely different note if we round up. So 59.52.9 MIDI value should be rounded down to 52. Because if we round up to 53, that's a completely different note and it will sound off key. So yeah. Okay, so we need to find a way to round down. Let me just Google search how to round down. This should be it. Rounds down to next. Easy. Math floor done. All right. So let's just quickly check how we do this. Oh, I can do this. All right, cool. We can round down by math floor. So what we've got to do is just do math.floor MIDI, and we just import math. Cool. Hopefully this works. Oh god. Oh my. Oh, it worked. Did it work? Oh, made at 3:37 p.m. my time. All right. Okay, this is gonna sound really weird, but let's just hear it. Oh, it's loading. A pretty big file, I guess. Oh, it's opening. Oh yeah, taking a long time to open. Um, if this works, then I might just spend a few more minutes trying to fix up the timing, then I'm gonna end this live stream. Yeah, let me know if you find this interesting. Like, I was a bit hesitant to do a live stream because I didn't know um how it will turn out, but it seems like it's okay. All right, it's not responding. Let's try again. Let's actually have a message that says this has been completed. And then we're just gonna do print successfully created piano cover. Yeah, it's only 1 kilobyte, which is very weird. All right, so again, it's only 1 kilobyte. That's not right. All right, guys, seems like we have to try fix this issue. Hmm. I think it's got to do with this. It's got to do with this. Actually, I should read the documentation. What am I doing? I should I should read the documentation. Uh, MIDI file. There we go. Okay. Mm, wait, is there one already in? Now, normally they have a instruction or manual in the library, so have to just read it. Oh, so weird. Do I have to put this in there? I don't know. Seems legit. Or would that create way too many tracks? We'll see. Um, is it possible to make the function accept non-integer values for more precise notes? I don't think so. I think the whole purpose of a midi value is that they're whole numbers. They're whole numbers that represent a note on the piano. So a C4 is wait, let me show you the chart again. So as you can see here, there are only whole numbers, they're just integers. So a C4 is only 60. You can't have like 60.40 or 60.72. It's only 60. So I think that's why we can only accept whole numbers. Yeah. Hmm. Oh yeah, it's good. I'm happy to hear that I find this relaxing. Yeah, I guess it's like watching paint dry, right? It's like yeah, it's therapeutic, therapeutic, ther, therapeutic. No, wait, how do you pronounce that word? Therapeutic for some people. Yeah. Right. Still 1 kilobyte. That's so weird. That's not right. Okay, we've got to fix this. Okay, once we fix this, then you're not rounding the notes though. Are you referring to the print output here? That's the stuff before I rounded it down. I rounded it inside the function here. So this stuff is printed in the other file. Yeah. What's going on? No, this can't be in there. This has to be up there. I just don't know why it's not. Duration is 0. Time is 0. And every time increment by 0.25. Then what's time up here? Oh, did we forget to write to the disk? Is that why? We forgot to write it to the disk. If this might be it. This might be it, and this should be. Yeah, timing is hard. I've yet to figure that out. How we're gonna do that. All right, it seems like it's working because it's loading. Yeah, so the key challenge is that Oh, it worked. Some notes, um, we're grabbing notes every millisecond. So what we're doing right now is we're playing every note. We're not taking into account the timing of each note. So that's difficult. But I think I have an idea around that. My idea is that if we see repeating notes over more than um actually that might not be a good idea. I'll think about that later. I'll think about that later. Oh, what? Still 1 KB? Are you for real? No. Why? Oh, it's 57. No. Alright, let's just play it. Let's just see if it actually works. Nah, it's not working. I think yeah, okay, yeah, I think it's also the time or duration. That could also be, it's probably it. How did I? What was the original? What am I reading? Tempo. Where does tempo come in? Oh, right. Okay. Okay. So that was actually not meant to be here. That was just supposed to be here. My bad. Tempo. We don't need this. I think that's it. Track. Duration 0 is nullifying the notes. See? Ah, do we have to increment duration? Let's see how they did it. Duration 2. I think duration. Wait, let's just see if this works first. We'll see if this works first. Permission denied. Oh wait, I got this open. No wonder why I couldn't write. Duration was 1 at the beginning. Ah, that makes sense. That 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 probably works. Alright, let's try it. Let's just try that. Oh my, oh, I'm so stupid. It's scoping error. Oh my. It's time supposed to be up there. That once it's up there, then time can be incremented. Oh my. That should work. That should work. If this doesn't work, then oh man, that it's the scoping. Yeah, that's right. I saw that as well, Anderson, so should be correct. All right. 129 kbs. Oh yeah. Oh, that's much healthier. That is a healthy file. All right, let's play it. This is gonna sound random, I swear. What the heck? All right, so we have a music track, guys. Like this is like 90% of my coding struggles. I code something that's in theory correct, but then one variable is in the wrong scope, so I end up spending so much time trying to fix it. So in this case, time's supposed to be outside of the for loop, because if it's inside the for loop, it'll never get incremented, like it'll never be updated. The function only taking zero as the time. That's why I could never create a track. So you have to put it outside so that the time variable gets incremented. You know what I mean. So all right, cool. So that's basically done for getting the sample out. Now I have to work on the timing. Okay, this is gonna be hard. Timing. Let's observe the numbers first. Actually, let's just first convert all these values into um just do it in the yin algo. So midi conversion, we're going to append this. Yeah. All right, so that should deal with that. So when we print out the values, it should look nice. Okay, so here are our MIDI values. So let's observe the values and see if we can figure out a timing. So what I'm going to try to do here, so we're now up to steps. So we've done all three steps. So I can technically end this live stream, but let's just go further, all right? Let's just work out the timing. First of all, we need to identify um, groups. Actually, first we identify um, how many MIDI notes are played per second. That way we can find out if a MIDI note represents a millisecond. So we need to find out what is the duration of each MIDI note. From here, we can take a unit. So we then get our unit, and then we're going to identify groups of units. I'm going to make an assumption. An assumption is that, actually, so let's just go back to our music theory. So, so we have to try identify groups between quarter beats, half beats, 1 beats, 2 beats, 4 beats. These are the 5 different types of lengths that these MIDI values could represent. And it's just a matter of grouping them. It's just a matter of grouping them. So for example, let's just assume, like for example, if each MIDI note is equal to 1 millisecond, and how long is a half beat? How long is a quartet. Yeah, that'll work. All right, we got some maths. That's nice. All right, let me draw this out for everyone. Oh, all right. So we have a list of oh, it's not working again. So we have a list of values. Let's just say this is 40, 40, 40, 40, 42, 42, 43, 60, 60, etc. They'll be repeating midi values. As you can see in our output, there are lots of repeating values. You can see here there are a bunch of 55s that go in a row. So obviously these 55s, each of them don't represent a note. It could be that 3 of them are one note and the other 2 are another note, or it could be all 5 of them are one note. So we have to try and work that out. How can we group these values so that it represents the timing of each note in the original music track? So I have to try and come up with a way to kind of group these properly. So for example, these could be like that. So how do we do that? So we need to work out the timing of each beat. So first I need to, so this is our clue. I need to work out how long do these last in milliseconds. Oh wait, there's tempo. Oh, there's tempo and stuff. And beats per, oh, there's tempo. Oh no, that's gonna be so hard. Oh wait, we can look that up. We can look that up, right? I'm pretty sure there's stats on music tracks. Uh, There should be. There should be stuff on that. Oh my, okay. All right. Oh yes. All right. So this will be very helpful. We can look up the stats of a music track. So my time BPM is 100. So let's just do that for now. BPM is 100. Where's BPM? Right, that's BPM. Oh, um, just put it down here. All right, let's just try that. Let's just see if this works. Can your program detect silences? That's where zeros come in. There are zeros in our list, so that should represent silence. Okay, that's 100 beats per minute, so we've got that. All right, so let's just record all of this down, so that they keep switching back and forth. BPM is 100. Loudness, we don't really care. And that's it. And just say duration is 354. Okay. All right, that's cool. Okay, what do I do now? Hmm. All right, so let's just see. All right, so 3 minutes 54 is 180 seconds. Oh, no, we can just do 3.54 times 100, which is 354. So in theory, there should be 354 beats. And then MIDI list, we should do number of MIDI values divided by 354. Does that work? So that determines how many MIDI values per beat. Is that helpful? We're making lots of big assumptions here, so I'm not sure if this is gonna work. Can't the program take that, or do that have to input every time? We have to try write an algorithm so that the program can detect this sort of stuff. If you're referring to tempo, I'm pretty sure there is a way to find it, but we can. It's easy to just look it up and just input it. But yeah, if we want to convert multiple K-pop tracks at the same time, then yeah, it would be nice to create an algorithm that detects tempo. But we're just doing one track for now, so we can just input in ourselves. Okay, we have MIDI verse beat. Is there a relationship? Need to learn some music theory. Okay, that was nothing. Uh, beats per minute. I'm trying to find the connection. Yeah, I'm trying to find a connection between beats per minute and the number of MIDI values that we have. And I'm wondering if beats per minute can help us determine a way to group these MIDI values. Hmm. All right, so we have 14,000 MIDI values. Actually, we should go by with what our program suggests. So 234 seconds divided by, sorry, that's wrong. 234 divided by 60 times 100, 290. That's you're right. So thanks, Steve. You're correct. There's actually 390 beats. And 1,453 divided by 390. There are 37.57. Let's just round down. 37 MIDI values per beat. But beats are only for like the drums and like the hi-hats, right? What we have here is the whole melody. So how do we do that? For those who are just coming in, The challenge is, given the beats per minute and given a list of MIDI values which represent the entire melody of a song, how can we write an algorithm that can detect which repeating MIDI values are actually one note? Because so far, what the program does is it treats every MIDI value as an individual note, which means we have a very random track, even though its data represents the original track. If I can't figure this out in the next half an hour, then I'm just gonna end the stream. So yeah, and we're gonna continue this in part 2. So yeah, how are we gonna do this though? Let's listen to the original track first and see how it actually goes. Can't really hear the beats though. Okay. First of all, let's just try to find how many MIDI values are there. So 14653 divided by 234 seconds is around 62 MIDI values. 62 divided by 1,000. So the ratio is 62 MIDI values per 1,000 milliseconds. So 1,000 divided by 62 is 16. So they're around 16 milliseconds. Okay, so each MIDI value represents 16 milliseconds. Okay. So So each MIDI value is 16 milliseconds. Then we can search how many milliseconds in a quarter note at 100 BPM. Oh, this is gold. This is gold. Alright. Oh, and I have to sign up. Cool. Nice. Alright, we're gonna use this calculator. Alright, so this is perfect. Bless this website. Bless this website. Okay. So at 100 BPM, a quarter note equals 600 milliseconds. So a quarter note lasts 600 milliseconds. So that will take up how many MIDI values? 600 divided by 16. That takes up 37.5 MIDI values, around 37. Alright. Oh, there's so many of them. Half note. Okay. A half note lasts for 200 milliseconds. And a whole note. And a whole note is 200 milliseconds. So this is just times 2. So 37 times, so 38, that's 76-ish. And 76 times 2 is a oh, no. Yeah. So we got that information, but we still don't know how they group up though. Still don't know though. Yep, I'm trying to compete against those K-pop piano cover channels. If they can pump out piano covers in an hour, I want to pump out piano covers in 1 second. Yeah. But it will take like a long time to write a program. It's just harder than I thought. For those who just joined the chat, this is our progress so far. I'll play the track that our computer generated based on the data that we've extracted. Yeah, this is how it sounds. This is what it sounds like. So as you can tell, it sounds very annoying. That's because the program is treating every MIDI value as an individual note. Obviously, there are some MIDI values which only represent one note. So we'll have to try find out how do we work out a way to group these MIDI values so that we can play the proper notes. So far I've been using like these conversion websites to find out how long does a quarter note last at 100 beats per minute. So I have these sort of findings right here. But we still don't know whether a thing is a quarter note or MIDI note. Actually, wait. All right, this is the quickest note. A 64th note is something that runs for 37.5 milliseconds. All right, so a 64th note, something that goes by really quickly. is 37.5 midi. Oh no, it's 37.5 milliseconds, which is around, that's like 2.3 midi values. So the minimum, so we can establish a domain. So minimum is 2, maximum is 152. So when it comes to grouping, we can group in twos as the smallest group, or group them in 152, which is the biggest group. And now I have to work out what's in between. Wait, maybe, hang on. Let me just get my charger. Just enjoy this track for now.